Hello everyone, welcome to you in my YouTube channel. Today it is the second video of chapter 1 number system, and today we will represent irrational numbers on the number line like square root 2, square root 3, square root 5, etc. These are irrational numbers, and today we are going to learn how to represent them on the number line. So first I will draw a square root spiral. This is the activity of chapter 1, and this activity you have to do. So we need geometry box. With the help of geometry box, ruler, compass, protractor, we will represent square root 2, square root 3 by drawing spiral, square root spiral. So what you have to do, you take your ruler and you have to decide that you are going to construct a small spiral or a big one. Then you have to select the scale. So first I am drawing number line with the help of a ruler. You have to draw it. This is a number line. Locate 0 on the number line. So here I took 0. Now the remaining numbers on the number line, you have to decide at a distance of 1 centimeter you want to represent, or at a distance of 2 centimeter you want to represent. That is your choice. Here I decided then that I will represent at a distance of 2 centimeter, because 1 centimeter will be very small, very difficult to use compass, very difficult to construct. That's why I decided 2 centimeter. So this is a number line. Here I took 0. Then I will take 1 centimeter. It is 1 centimeter. It is 2 centimeter. And then it is 3 centimeter, and so on. You have to mark it. This distance must be equal to this distance, equal to this distance. I decided 2 centimeter. So after 2 centimeter 1, then again next 2 centimeter, then 2, next 2 centimeter 3, and so on. So to draw a square root spiral, first you have to locate square root 2 on the number line. For that, this we took 2 centimeter. So here, with the help of protractor, you have to draw perpendicular line. Perpendicular line must be 90 degree. This this is 1, but actually we took 2 centimeters. So here also I am going to take 2 centimeters. So this is 1, so I will say it is also 1. And then you join it. Join this. Now see, this is a right triangle. It is 1, it is 1. It is A, it is B, it is C. Then what is this? In a right triangle, if two sides are given, then with the help of Pythagoras theorem, you can find the third side. So Pythagoras theorem is square of hypotenuse. So what is hypotenuse? This is hypotenuse. So AC square is square of hypotenuse is equal to sum of squares of the remaining two sides. So this is hypotenuse. You must know what is hypotenuse. It is a side which is opposite to 90 degree. it is equal to the sum of squares of the remaining two sides. So it is 1 plus 1. So AC square is 1. So AC square is 2. So AC equal to square root 2. So this is square root 2. So now if you want to represent on square root 2, you need compass. I don't have compass, so I'm using this. So here, keep the needle of compass at 0, and then you take it at 1 and draw an arc. Then that arc will intersect number line at a point. That point represent square root 2 on the number line. Similarly, if you want to represent square root 3 on the number line, with the help of square root spiral, I'm telling you, because another way is also there, but I want to tell you two things: spiral as well as representing square root 2, 3, 5, and so on the number line. Then now you see the hypotenuse of this triangle. This is first triangle, this is the hypotenuse. So at this point, with the help of protractor, you have to draw 90-degree angle. So I'm drawing 90-degree angle here. If angle is not 90-degree, then you are going to get a wrong construction. This angle should be 90-degree. On hypotenuse, you have to draw 90-degree angle. Here we took 2 centimeter, but we are saying it is 1, right? To enlarge our diagram. Now here again you take 2 centimeter. Here I took 2 centimeter, this one. So now this distance equal to this distance equal to this distance. So this will be 1. And then you join it. Now again it is a right triangle. So if I will draw this right triangle here, this is 90-degree. 90-degree, it is 1 and it is square root 2. Again, if you use Pythagoras theorem, so hypotenuse is square equal to square of this side plus square of this side, square root 2 whole square, that is square root 2 into square root 2, that is square root 4, and square root 4 equal to 2 plus 1. So hypotenuse is square equal to square root 3. Hypotenuse is square equal to 3, so hypotenuse equal to square root 3. So this hypotenuse will be square root 3. Now you want to represent square root 3 on the number line. Again we need compass. See, this is square root 3. If you continue this one, this is first step, first right triangle, second right triangle is square root 3, third right triangle is square root 4, next right triangle is square root 5, next right triangle is square root 6, next square root triangle is square root 7. This all representation, that is called square root spiral. So suppose you want to continue here, then again you have to draw 90-degree angle on the next hypotenuse. 90-degree, exactly 90. If angle is not 90, then wrong construction. So this is 90-degree. With the help of protractor, you can make it 90-degree. And then again you have to take 1. So I'm taking 1 here. 1 means 2 centimeter, because we decided 2 centimeter equal to 1 unit. Length is 2 centimeter, but we will say 1 unit. So here I took, if I will name it A, B, C, D, E, then I will join this one. It means same thing we are doing. And if I will, with the help of compass, if I will represent it on a number line, we know square root 4. This is square root 4 and it is exactly equal to 2. So this represents square root 4. So you continue this one, then you are going to get a spiral. This is your one activity in chapter 1. So I'm moving to the next thing. Some irrational numbers can be represented on the number line directly in one or two steps. No need to draw a spiral. They are square root 5, square root 8, square root 10. How to know that which number, square root of which number directly you can represent on a number line by using Pythagoras theorem directly in one step. Condition is the sum of square of two numbers must be equal to 5. Yeah, 5 equal to 2 square plus 1 square. 8 equal to 2 square plus 2 square. 10 equal to 3 square plus 1 square. So this is the condition. If the sum of squares of two numbers equal to radicand, it is known as radicand. So square of 2 plus square of 1 equal to 5 can be represented on the number line in one step by using Pythagoras theorem. So now I am representing square root 5. So first I will draw number line, and then locate 0 on the number line, it is 0. And then again at a distance of 2 centimeter, it is 1, it is 2, it is 3, 1, 2, 3. So I'm doing this one. The bigger number is 2, so I will represent 2. This is 2. Suppose it is A and it is B. So first number is 2. So here you draw perpendicular passing through 2 with the help of protector. Perpendicular, if it is not perpendicular, then again your construction will be wrong. Now see, it is perpendicular. This is exactly 90 degree. Now the second number is 1. 1 means 2 centimeter. So I'm taking 5 centimeter on the board, but on notebook you take 2 centimeter. It is 1. This is 2 and it is 1. Join it. Now it is hypotenuse because it is 90 degrees, so it is hypotenuse. So AC square equal to this square, 2 square, and this square. So AC square equal to 4 plus 1, AC square equal to 5. So AC equal to square root 5. So this is square root 5. Now we want to represent on the number line. We got this distance represent square root 5, but keep it on the number line. So I'm taking this on the number line with the help of compass. This is sorry. This is compass. By using compass you have to do. So this point represent square root 5 on the number line. Same thing you have to do. In case of square root 8, what you do? 2, then perpendicular, then here you have to take 2 because the second number is 2. And then the same process you can get square root 8. Similarly, if you want to represent square root 10 on the number line, so this is 3. So at 3 you have to draw perpendicular. The second number is 1, you have to take 1 here. Join it, that hypotenuse will represent square root 10. and then with the help of compass represent it on the number line. So this is about the representation of irrational numbers on the number line. In this case, these radicand, they are natural numbers. They are natural number. And there is a question in textbook, in CBSE textbook, when this radicand, it is known as radicand. Okay, this is decimal number. So if it is a decimal number, so how to represent on the number line, that I'm going to tell you. Represent square root 9.3 on the number line. Because this radicand, this is known as radicand. It is decimal. So we can't use Pythagoras theorem like the previous one. Here we are going to use semicircle method, I am telling you, to differentiate them. Actually, in both cases, we are using Pythagoras theorem. But here to differentiate them, it is not a natural number. I am saying semicircle method. So in this case, what you have to do, draw a number line, big number line. And locate 0 on the number line, and then negative of this radicand 9.3. So it is, I will take 2 centimeter because this is a big number, -1, -2, -3, -4, -5, -6, -7, -8, -9, -10. So on board, it is not possible for me to take exactly 9.3. But with the help of ruler, you can take exactly 9.3, and you take 1 centimeter, that's better. Easily you get 9.3. So 9.3, this is here 9.3. I mark here, and this point I will say it is A. This is A. So first step, locate -9.3 on the number line. -9.3 and 1 on the number line. Say A and B. So 9.3, whatever number is here, that is as A, and 1 as B. One, 2, 3, 4. It is as B. Second step, draw perpendicular bisector of AB. With the help of compass, you can draw perpendicular bisector of AB. And how to draw it, that I'm going to tell you, just see. Take your compass and radius more than half of AB. See, I hope this radius is more than half of AB. one arc here, and one arc here. Same thing you have to repeat from another point. Same thing you have to repeat from B. One arc here and one arc here. With the help of compass, what you do? Draw the perpendicular bisector of AB. How to draw it? Taking A and B as center, taking A and B as centers, radius more than half of AB, draw arcs on the both sides of the line segment in such a way they must intersect each other. See, both of them are intersecting, both of them are intersecting. Now, with the help of ruler, this is a ruler, see, a ruler. You have to mark the point on the number line. I think it is here approximately. You mark like this, one mark here, one marking here, and one marking here. To get midpoint of AB, say M. Why we are drawing this perpendicular bisector? To get the midpoint of AB, and that midpoint we will say as M. Third step, draw a semicircle with center M and radius MA. This will be the center and this will be the radius, because it is M is a midpoint. This is the center and AM is a radius. So AM equal to MB. So if you draw semicircle, your semicircle will pass through from A and B 100%. When you draw it, then semicircle will pass through from A and B. So this is the semicircle. We don't have to complete circle. On the line, on the above the line, we have to draw it. Now next step, fourth. At B, at 0, this is 0, draw a perpendicular to intersect semicircle at C. So draw perpendicular. So this is perpendicular. This angle must be 90 degree. Then this length will represent 9.3. By Pythagoras theorem, if you want to verify, you can verify it. This is the radius of circle. This radius equal to this, see, MB is radius. If you subtract 1, you are going to get this point. So this is given by using Pythagoras theorem. Again, I am telling you, this is equal to MB. You can get MB on the number line, see, you can read it, 1, 2, 3, 4, 5, 5 point something is MB. So like that, with the help of Pythagoras theorem, you can verify it, and then you can turn it on the number line. You can draw it on the number line, because see, it is square root 9. My semicircle is not exactly correct. That's why I'm not getting. But I saw this is 9.3. Square root of 9 is 3. So this must pass through after 3, not before 3. If it is passing through before 3, then that is wrong. So I drew this rough semicircle, then I'm not getting exactly, but I know it. This length represents 9.3. This length will pass through from after 3. So that is the representation of irrational number. Radicand is 9.3, that is decimal. So now this also over representing irrational numbers on the number line. There are two types of question. One, radicand is a natural number. Second, radicand is a decimal number. Now we are going to learn how to express non-terminating repeating decimal. Express non-terminating and repeating decimals. Repeating means recurring in the form of P by Q. This is very important question. Mostly it's coming in examination. So there is a rule. What you have to know, this table is enough to learn it. Number of digits under the bar sign, multiply by under the digit, under the bar sign, if there is one digit, you have to multiply by 10. Under the bar sign, there are two digits, multiply by 10, 100. If three digits, multiply by 1000. When I will do question, then you will understand where you have to multiply. I'm taking one question. That is question number 3, exercise 1.3. Exercise 1.3, question number 3, first bit. Number is 0.6 bar. I will let x equal to 0.6 bar. Now I'm going to tell you steps. That is steps you have to follow in every question, the same type of question. Then you write the number without bar. This bar means telling 6 is repeating. Repeating how many 6 we can write? Infinitely many. But we will not write all, and it is not possible to write all 6. Nobody can write. Then here we will write dot dot dot, and this we will take as equation 1. Equation 1 you have to multiply by 10, by 100, by 1000. In depends on the number of digits under the bar sign. Here under the bar sign only one digit, so multiply this equation by 10. If under the bar sign there are two digits, multiply equation 1 by 100. If under the bar sign there are three digits, then multiply equation 1 by 1000. That is the rule, is very simple. So multiply equation 1 by 10. So multiply it. 10x equals 10 into 0.666 and so on. When you multiply, this decimal will move to the right side. When we are multiplying by 10, 100, 1000 and so on, decimal is moving to the right side. If you divide by 10, by 100, by 1000, it will move to the left side. How many places? 1 0, so one place. So 10x equal to 6.66. But here, very important thing. When decimal shifted there, now we have only 2 6 remaining. Then you see the number of digits after the decimal, 1, 2, 3. Then here also you have to write the number of digits after the decimal, 3 digits. Actually, there are infinitely many digits after the decimal. But how many digits we wrote 3 digits out of infinitely. So here you have to write 3 digits out of infinitely. So that's why one more 6 dot 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 equation second. Number of digits after the decimal sign, 3 digits are written. Number of digits after the decimal sign, 3 digits are written. There are infinitely 3 are written. Here also they must be same. Otherwise you are not going to get the correct answer. Now next step, in every question you have to follow this one. Second minus first. In every question you will get one equation, two equation, then subtract it. You will get the answer. So now 10x equal to 6.666. Equation 2. Second minus first means second equation you have to write first. Then under the second equation you have to write the first equation. So x equal to 0.666. When you write this, then write in a way decimal must come in the same column. Otherwise subtraction will be wrong. Now subtract it. Minus 10x minus x, that is 9x. 6 minus 6 0, 6 minus 6 0, 6 minus 6 0, like that. Here 0, no need to write, and 6 points. So x equal to 6 by 9 and it is equal to 2 by 3. So this is the representation of 0.6 bar on the number line. Now I'm taking second one, and third one will be your homework. It is second one, 0.47 bar. Very carefully you have to observe the number, the digits written under the bar sign. Only 7, not 47. So let x equal to 0.47 bar. So which digit will repeat? 7 will repeat. 0.4777 and so on, equation 1, because under the bar sign 7 is written, so only 7 will repeat. Suppose bar sign 047, this is under the bar sign 4 and 7 both are written, so this is 474747 and so on. Now same situation, under the bar sign there is only one digit, so you have to multiply equation 1 according to the rule by 10 only. So now multiply equation 1 by 10. So 10 into 0.4777 dot dot dot. When you multiply, this decimal will move here. So 10x equals 4.777. But you see, first equation, after the decimal, 1, 2, 3, 4 digits. And here, 1, 2, 3. One more 7 you can write. There are infinitely many 7. So number of digits after the decimal in equation 1 and equation 2, they are same. So now second minus first. 10x equals 47777 and x equals 0.4777 and minus 9x equals 0 0, here dot dot dot, here 0, 7 minus 4 is 3 and it is 4. So x equals 4.3 by 9, simplified by 10, multiplying by 10, 43 by 90, it is in the form of p. Representation of 0.47, it is equal to 43 by 90. It is decimal form, it is fractional form, that is in the form of p by q. And third bit you can do in your home. Question number 4 you can do in your home. Now I'm going to tell you question number 8. If you are understanding what I'm teaching you, I need your feedback. So now the next question 8 is exercise 1.3, question number 8. Find 3 different irrational numbers between 5 by 7 and 9 by 11. 5 by 7, 9 by 11. Which number? irrational numbers. What is irrational number? Non-terminating, non-repeating decimals are irrational. All square root with prime denominator radicand irrational, square root 2, square root 3, square root 5, and so on. So we want to find three irrational numbers. Three irrational numbers. So we know irrational numbers here, they are non-terminating, non-repeating decimal, and it is fraction. So convert them in decimal by division. 5 divided by 7 0 times. Then decimal we can write 1 0. 7 7s are 49. 1 1 0 we can write 7 1s are 7. 3. Then again 1 0. 7 4s are 28. So now approximately 7.14 the value of this number. And second number 9 11 0 the 0 decimal 11 8 the 88 2 11 1 the 11 9 11 8 the. So approximate value of this. So the numbers were given in fractional form. We converted in decimal form because we know the irrational numbers which we have to write. We know that irrational numbers are non-terminating, non-repeating decimals. Irrational numbers are non-terminating, non-repeating decimals. That's why we converted in decibel. So, and it is 0.14 this. See this one. So number bigger than this is smaller than this, and irrational numbers. So see, I'm writing 0.7303003003. It is a pattern of irrational number. This shows that 0 is increasing, so it is not repeating. That's why we are writing in this pattern. Now 0.74, then 0.75. So these are three non-terminating and non-repeating decimals. Bigger than this, smaller than that, this, so they are three irrational numbers. So now today it is and I'm going to end this video. I need your support. If you are understanding, you should tell me that it's okay or give your suggestion. Okay, thank you.